Hi, and welcome to the Mini Pallet Project Part 2. In this part, we'll be making the mill vise pallet, and let's just get right to it. Alright, so just quick beginning. I'm not going to show you the details of all this, but I am going to face this on all sides and square it up and prep the stock, and then we'll go to drilling and tapping, and I'll show you an example of each, but that's probably more than enough, right? Okay, so one down. This one is dimensioned more or less and surfaced. So next step will be to put slots in around the sides, going all the way around so you can clamp it down to a flat table like the mill table if that's what you want, or it'll also be able to be held in the vise jaws, so trying to get maximum flexibility. And then of course I got to drill and tap a bunch of holes and we should be good to go. So to start cutting the slots along the bottom on all four sides for mounting flat to the mill table, I jerry-rigged a stop, and then what I'm going to do is I'm going to find the zero of this corner, which will be my datum point, and then I'll just do the slot here, move over, do the slot here, flip it over this way, do it again, then do it on the high side. And the beauty is the datum will remain the same since I'm locked here between the back of the vise jaw and this point here. So I can just go and do it all at one fell swoop. So anyways, I'm sure you've seen this before, but here's my electronic indicator. So you go until the light's on. So you get it just as the light's going on, and then you zero your y-axis in this case, and then you come up and you move over another 100 thousandths this direction, and then hit zero again. So I found my datum points. Let me put up the milling cutter and I'll show you one of the slots, and the rest I'll do off camera. So for this next part, the slotting we're going to use, I'm going to use this stubby 3/8 inch cutter. It's a 3 flute, and I'm only going 3/8 inch depth of cut. I'll use my quill depth to set that depth, and let me set this up and we'll go. There we go. So I can lightly file this, and if I did this correctly, be able to get my hold downs in here, which I can. They're at an angle, so get a good bite on it to hold it flat, and we'll be good to go. Okay, so I've done both slots. Now I'm going to pull this part out and flip it lengthwise so that it's lined up the same way. So the slots will end up on the same side. First I gotta make sure I don't get any chips inside here. Make sure it's flush and tight, and go again. And that's it. We'll be back in a sec. Okay, so next I'm going to flip this up on end, and we're going to do the last two sides. They only get one slot in each. I've got versatility this way. Gentle. So this isn't the strongest position of the vise, but it does keep my zero, and this is such thick material. I'm going to pretend I can get away with it and try it. Okay, so finished with this step. So I've got the hold down slots put in, and I'm just going to take some fine sandpaper and relieve that edge. And next it's pretty much drilling holes and tapping a whole bunch. So anyways, can be held down from any side, just trying for maximum flexibility. Alright, so I'm back on the mini pallet project, and it's been a while because I had to make another tool to get here. But so the last thing I finished was grooving, cutting, milling in the slots on the sides, and that would allow me to hold it down flat to this table if I decide not to use a vise. Although one of the big advantages of a mini pallet is to use it in a vise. The project I just finished was my tool stop, my table mounted tool stop, and I left my columns so long on it so that I could come from either side. So it obviously doesn't need to be as tall if it's on this side, but if I wanted to mount it over here, it would have to lean. So I left it long. You're seeing it in action here, and so I can easily remove this part, put it back gently, and be right back where I started, because once I find zeros here, I'm not going to have to keep doing that when I take this out. So my first step here, now that I'm at this stage, is I'm going to mill some V-slots in a cross formation so that I can put round parts and have them not rotate, and I know they'll be oriented horizontally correctly. So it'll be for non-critical parts, because if it was critical, then you probably have to use a dial indicator to indicate it in, but I'll make it as accurate as possible. So I wanted to put these slots in, but then I found that the only V-cutter I have is a 30 degree, which I think is a little too narrow. I really prefer 45 or 60. So what I'm going to do is, instead, I'm going to do something a little unorthodox, and I'm going to use a wood cutting bit. And since it's carbide and this is only aluminum, shouldn't be a problem. So we're going to give that a shot. All right, so because this is a wood cutting bit, I am going to use the mill running much higher speed than I normally would. I mean, these bits are designed to work 20,000 RPM kind of thing, 15, 20,000 RPM. Obviously my mill doesn't go anywhere near that high, but I'm going to be going slowly, and it's hard material. So I'm going to run it at 3,600 RPM and see how that goes. I'm going to take a 16th pass. So it looks like it's working, but the finish is not great. It looks pretty rough, so at some point I'm going to have to get a proper end mill for this. But in the meantime, this will have to do. Focus! Alright, I'll be right back. So when I was prepping to cut the vertical one, I ran into a problem where I ran out of table motion before this actually couldn't clear the parts. So what I had to do was loosen this bolt, and then push the whole head forward just a couple of inches. You see the dovetail sticking out now, and that's a big advantage of Bridgeport style mills, is that they're so flexible. So I can actually push this head a whole lot farther forward than that. As you can see, there is a fair amount of slack here in the back, so it can come forward quite a few more inches. So anyways, that allows me to get clearance and actually do the entire V-groove in one pass without repositioning stuff. So nice feature. People with mills probably are already aware of that, but I thought I'd point it out. And I'm going to do the vertical slot. So while the purpose of the V-slot is not affected too much, so they hold the parts square, and round parts don't rotate very easily, just a little bit of force down and they can't twist. The finish with the wood cutting bit is really terrible. I guess I didn't expect a whole lot more. It wasn't even an expensive wood cutting bit, it's just the only one I had. So I recommend you see if you're going to do this, to find a proper metal cutting bit so you can get a better finish. I'm going to take some sandpaper and a square block and get in here and see if I can clean out some of the, looks like almost welded on material, like it squeezed the aluminum around a bit. Anyways, I'll be right back. So quickly, another lesson here is to teach yourself to check visually, because I noticed that when I was really close to over Y0, Y was no longer reading 0, and then I remembered, oh, yeah, you moved the whole head forward, which just screwed up your Y0 point. So I guess a key thing to remember is to always make sure visually things are doing what you expect them to do. If not, stop and double check to save yourself a lot of trouble. So I'm refinding 0 here, and I will move along. Alright, so I'm ready to drill the first hole. Yay! Because we have 40 of them, so I will drill the first one here and move right along, and I will bring you back when I'm ready to tap. And then after we're all done, then we have to drill, tap, and ream these holes for the pins. So what I've done is I am drilling for 1024 tap all the way through, and then I'm going to use a 1/4 inch drill and drill down and ream for a 1/4 inch pin an inch down. So I can use a 1 inch dowel pin, but I can put a set screw in the bottom and change the height of the dowel pin in case I want it to be low profile, so I don't need to keep a whole array of dowel pins in place. So we'll come back for that, don't worry, and I will see you in a while. So while I've been working on this, I've had a serious problem. Probably one thing because it's so thick. It's 2 inch thick material, or 1.5 inches, I forget. And my problem has been that the flutes of the drill bit clog up. I've been using my Cool Tool 2 with a acid brush, standard thing, pecking very small pecks to keep the chips small. But still, I had to take my scribe and clean the flutes out between cuts. On the last couple here, I've been varying also all kinds of things too. I started with, you know, low speed, and I worked the speed up to see if that would improve it, and that helped a little bit, made a little bit smaller chips for this size drill bit. But ultimately, the solution was an old toothbrush that I've been using, and besides using WD-40 instead of the Cool Tool 2, which may or may not have made the big difference, because I think it's the toothbrush. I go like this down the drill bit as it's running, and it clears the chips out, and because it's soft plastic, it won't damage my drill bit. So I'm going to do one more, and I'll come back and I'll show you what it looks like. Okay, so let's do the last hole. A little bit of WD-40. I've always hesitated to use WD-40 anywhere because if it stays long term, it turns into sticky goo, so not a big fan, but seems to be working really well for this. And it's got a good reputation with aluminum, which is why I switched to it. The Cool Tool 2 might also work just fine. The toothbrush, I think, is the key here. And lots of really small pecking. And that's it. Last hole drilled. And there's a little bit of clogging, but not bad. So anyways, that's just my thoughts on this. Anyone else has any input? Always love to hear. Please leave in the comments below, and what you tell me may help everybody. Alright, let's get ready for tapping. So in case you're curious, even drilling small holes, that's how much swarf I got off of the 40 number 25 drill bit holes for 1024 threads. Quite a bit. So on this next tapping stage, I have a deep reach tap. It's the kind of tap that pushes the chips forward through the hole, and since these are all through holes, I was hoping this would work. To be honest, I don't know if you can actually tap 2 inches straight with one of these, at least in one go, but I'm going to give it a shot. What I'm going to do is turn my mill to the slowest speed I can make it. Lots of lube, and let it draw itself in, and we'll just see what happens. So we're going to give this a go at 50 RPM. To be honest, I don't know if this is going to work. I don't even know if this is a good idea. Someone more experienced drilling deep holes could probably tell me, especially in something as sticky as aluminum. But anyways, we're going to give it a go here, see what happens. There's actually a good turning of chips out the bottom, so this might not be such a bad idea. So it actually was working pretty well. This is what was coming out the bottom, and it looked like it was working. Ultimately, it became too much friction, and the chuck started slipping. That's why I'm grabbing on the round part, just to protect things from breaking. But maybe a little more lube, and I'll be able to get it to go down further. I'm not quite sure. I might have to just be content with a partially tapped hole. Actually, it made it all the way through. More turnings just like the other ones, and anyways, that's what the turnings look like. So I'm going to do the rest, and don't want to bore you with the tedium, and I'll be back. So this next stage, I've drilled these holes here, which are going to be for the pins. So I drilled them number 25 drills so I can tap the bottom of them. Now I'm going to follow along with a drill just under 1/4 inch and drill them all. Then I'm going to ream them all to 1/4 inch, and then I'm going to come back and tap them all 10/24 so that the bottom inch can have a tap, a set screw in it that I can use to control the height of my pins. I didn't know if that was going to be useful or not, but I thought it wouldn't be too much extra work, so I thought I'd do it. So I have reamed each of these to 1/1000th over 1/4 inch, 0.251. And last step is I need to tap the bottom inch of each one of these holes for a set screw. All right. So here's the mini pallet completed, and for more of an overview of what it can do and what features I put in it, check out part 4 of this video series. I saved the testing of it for that. Thanks for watching. See you next time.